You got it? If you know what you're doing, you should be done by now, to be honest, at this point. So a rhombus, slanted square, so that's one property. If you're talking about the side lengths, that is one property. It's not like you have like 4 properties there, okay? That's one. The other one you can use is that the diagonals, they meet at a 90, so that would be good enough already. If you want to do a different version, these two sides are parallel. These two sides are parallel as well. And then you can, insert the fact that the diagonals meet at a 90, so that's a different permutation. Okay. Or you could, honestly, you could say that these two angles are the same. These two angles are the same.
Yes. Do you know where Mr. Foss classroom is?
Yes, it's the one over. I kind of look like Mr. Fast, maybe. All these two sides, all these two, 4 sides are the same. Okay, rectangle. I mean, come on, you should know your rectangles. You were either sleeping or skipping if you don't know what a rectangle is. Right? So these two are the same. These two are the same. One more permutation where you talk about lines being parallel. And you can do diagonals like this. Do they meet at a 90? They don't. They do not. But this one is the same as that one. And this, all 4 of them are the same, correct? Yeah. What am I doing here? All these stretches, they cut each other in half, but they're actually the same length, so they're all the same. That would also be okay. All right, keep going. Obtuse isosceles. I would do one of these. I just imagine the roof, and I'll just slap on 100 there, and I just mark these the same, or you can go 5 feet, 5 feet. Whatever you want to do is fine there. Doesn't have to be exactly like that, but just make sure it qualifies. Obtuse quadrilateral, not applicable, right? We do not have obtuse. They're all 60, 60, 60, so it has to be acute. Okay. There's no such thing as obtuse equilateral. A kite, there. You can talk about the diagonals also meeting at a 90, and that the short one is bisected. That'd be good. You can also talk about, this almost looks like they're all the same. That would be a rhombus actually, right? So you got to make sure. So these are the same, and these two measure the same. That's for sure. And you could say, hey, the short one. No, let's talk about angles. Which 2 angles are the same? The ones that are connected by the short diagonal. So this one is the same as that one. That would also be okay. All right, just a quick review. Let's go to 48 and just answer that one too. I can see that being a good candidate for an exam question, perhaps. 48, find x, y, z. It's a parallelogram. So out of the 4 shapes, remember what I kept on telling you? These add up to 180, correct? So if this is 73, then this is 107. Okay. So this is 107. What else do we know? This angle is going to be the same as that one. And these are, so I'm going to make an arrow going up there. So x is actually 73. Which means that this 107 is going to be down here, right? And how do we know what this is? Remember, hat, there's a 180 there. If you have the 107, every time you see something like extending, like even a triangle, if you have something that extends it, think of a hat, right? Supplementary angles. They add up to 180. So this must be 180 minus 107. That is 73. So you see a pattern that everything is either 107 or 73 here. Okay. So y is equal to 73 also. Done deal. Let's do the true and false before before we go over that take-home AC. You got this, right? For true and false, okay, imagine this. I want you to think of, we've got quads in general. And then we've got, I gave you a bunch of, there was the parallelogram. And I'm looking back, sorry, I have to look back myself here. Make sure I don't mix them up. This one right here. Out of the parallelogram came these two and also the square. Okay. So you can always say a square is a rectangle, a square is a rhombus. You can always say that, but you can never say that going this way is true. Like, is a parallelogram always a rectangle? That's not always true. You can always go this way, but you cannot go specific. Okay. So for a true and false, a square is always a parallelogram. You're going from specific upstream, so that is a false. Every rectangle is also a square. The word every is throwing us off. Not every rectangle is a square. For example, this is not a square. That's a rectangle. It's be 7, 3, like that. It's not a square because all four sides need to be the same. A rectangle is always a rhombus. That is also false because of the always. Because, right, a rectangle like this, let's say it's 3 and 7, is not a rhombus. A rhombus, we need all four sides the same. So a rectangle is not always a rhombus. A rhombus can never be a square. That is actually false. The word never. There are some rhombus. A rhombus could be a square. You're looking for the always or never. Okay, so this is also false. All right. I'm going to stop there.